So today, it would be important for us to discuss about illegal canceling. So let's say that we have an equation for a quadratic function like this. X squared is equal to 3x. So how would you solve this? Well, first we would get everything to one side. So in this case, we're getting everything to the left-hand side. After that is done, we should factorize. So in this case, x squared and negative 3x, they both share x as a common factor. And when you divide each of them by x, you will get what's inside of those brackets. So x squared divided by x becomes x, and negative 3x divided by x becomes negative 3. Now when you reach this point, if we use our Null Law, there is a product of two things which is equal to 0. Therefore, one of them will have to be 0, either one of them. So the solutions for this situation here would either be x being equal to 0 or x minus 3 being equal to 0. If x minus 3 is equal to 0, then x has to be 3. So the two solutions for this problem would be x equals 0 and x equals 3. However, we could have committed some mistakes. For example, if we assume that we can simplify this, so we start with the same function that we had before. And now let's say that mistakenly I have divided by x on both sides, and then I would arrive at x equals 3, which is only one of the solutions that we had before. Now, where did this answer go? Well, when we're dividing by x, we're neglecting that x might be 0. When we're dividing both sides by 0, we can only divide by numbers which are different than 0. So when we do this, we are assuming that x is not 0, which is not the case. So this is wrong. You cannot simplify those because you would assume that x would be different than 0. However, x equal to 0 is one of your solutions. Now, what if we had a completely different problem now? So, how would you solve x squared plus 3x is equal to 28? Try it for yourself. Now, first to solve this, first we would get everything to one side of the equation. So in this case, we will get this 28 to the left-hand side. So this is the same thing as subtracting both sides by 28, or simply getting the 28 to subtract. Since it was adding to the right-hand side, it could be viewed as subtracting to the left-hand side. So here we do have a quadratic, and we could factorize this. Now the simplest way to factorize this would be through sum and product. And to solve that, you basically have to look for numbers which sum to this middle number here, to your b, which in this case is 3, and product negative 28, which would be your c. If you look at your quadratic as a x squared plus bx plus c, right? So a few things that we can get from that data. First, product is a negative, So one of your numbers will be positive and one will be negative. Your sum is positive, so the positive number is larger than the negative one. So can you find two numbers which multiplied give you negative 28 and summed up give you 3? Well, it's fairly simple. 28, negative 28 may be expressed as negative 4 times 7. So 4 times 7 is 28. If I make one of them negative, that's negative 28. Now, since my sum is 3, the positive number has to be larger. And if I do negative 4 plus 7, I would get 3. This is a bit of trial and error. However, the easiest way is to look for any factor of your product. So 28 here, I could try 2 times 14. I could try 4 times 7. I could try several different possibilities to get this product, and I always have to check if my sum works. So in this case, negative 4 and 7 work. So I can rewrite my original equation as x minus 4 x plus 7 equal to 0. That's what we get when we factorize our original quadratic. So from this, we find our solutions to be x equals 4 or x equals negative 7. And if you notice, those are those numbers but with flipped signs. Now let's try another example now. So what about this case here? 5x squared is equal to 3x plus 2. So what should we do? Would you be able to solve that yourself? Well, first thing, we get everything to one side of the equation. So again, I'm getting everything to the left-hand side. Now, we have to look for common factors. Do these have any common factors? They don't seem to. Now, let's try and factorize. So for this problem, let's try and do split in the middle term. So this 3, let's make it become less 5 plus 2. And look how those numbers, they match instantly. This comes with experience. The more you practice, the more you observe that you can do that, right? Could you try sum and product? You could. Just remember that your first number there accompanying your x squared is 5. So when you into consideration your sum and product, you will have to multiply 5 by negative 2, right? And your 3 here. Anyway, by splitting the middle term, now we can factorize here 5x, so that's x minus 1 plus 2 x minus 1. And then we have our same factor on both terms, and then we can collect them. So 5x plus 2, x take away 1, right? Remember that if you split this, you get back to what you had before, 5x times x minus 1 and 2 times x minus 1, and you can go up if you want and get back to the simplest form that we had there. So what does this tell us? Well, this gives us the solutions. So if x minus 1 is 0, then x is 1. If 5x plus 2 is 0, then x is, and then you get 2 to the other side and divide by 5, so -2/5. When we're doing this, we are using the new factor law. We are considering that if the product of two things is 0, then one of them has to be 0. So if x is 1, it makes that 0, or if x is -2/5, it also makes that 0. Now, one detail here is that before you had split the middle term, if you're unsure what numbers to put there, take a look that you could investigate that by using product and sum. So if I take the number which is with my x squared and the number which is not multiplying any x, if I multiply them, I'll get the product which I'm looking for. So in this case, -10. The middle term here is the sum that I'm looking for. So this time I have a negative product and a negative sum. So negative product means I am multiplying something which is negative by something which is positive. And this negative sign here means that the negative one is the larger one. So which numbers can I multiply to get -10? Well, if I try 2 and 5, I'll get 10. If I make one of them negative, I'll get -10. However, my larger number has to be negative. My larger number has to be the negative one. So the sum makes a negative number. So the only difference here is to make 2 the positive one and 5 the negative one. So when we do 2 times -5, it's -10. And when we do 2 plus -5, that's -3. So -5 and 2, -5 plus 2. And then you would use exactly those numbers when splitting the middle term. -5 here and +2 here. And then you can move forward with your problem. So let's take a look at a couple more problems. So now we do have some fractions. And the only thing that we have to worry about when working with those is just to make sure that we're not doing anything that will make us kind of lose that understanding that my x might be 0 or might not be 0. We just have to be mindful of that when it's a denominator. Because, for example, here, x will have to be different than 0, right? Because it's a fraction. You cannot divide numbers by 0. So even if you get rid of this 0 here, you will have to consider that x cannot be 0. Because this is not valid if x is 0. So if you work it out, and at the end you reach a conclusion that one of the possible values for x is 0, you will disregard that. Because you know from this that x is different than 0. So, first thing we could do is cross multiply. So we would get x plus 5 is equal to 4, 9 minus x. Now if we expand those, we will get here x squared plus 5x, and expanding on the right hand side, we will get 36 minus 4x. Just like we did before, let's get everything to the left hand side. X squared plus 5x plus 4x. Since it was negative on the right hand side, when it comes to the left hand side, it will become positive, minus 36, which was positive, and then since we got it to the other side, it became negative. Now here we can collect like terms. So 5 and 4 becomes 9 and minus 36. So to solve this, we will have to use, again, any of the factorization techniques that you know. We could use, for example, sum and product. we're looking for sum equals 9 and product equals negative 36. Now you could stop here to try and figure out what are those numbers, but I will just carry on and show you. So 36, if we try to look for possible multiplications, let's forget about the sign first. We could do 2 times 18. We could do 3 times 12. We could do 4 times 6. No, sorry. 4 times 9. 6 times 6. And so on. Right? If we continue here, we'll just flip. And then we'll have 9 times 4, 12 times 3, and such. Our sum is positive. So the larger number is the positive one. So minus 2, minus 3, minus 4, minus 6. And now what we have to look for is, are any of those combinations equal to 9 if I sum them? So if I sum negative 2 and 18, I will have positive 16. So it's not this one. Negative 3 and 12, if I sum them, yeah, that's positive 9. So this would give us 5 and this would give us 0. So yeah, that's negative 3 plus 12. Therefore, this quadratic here can be simplified as x minus 3, x plus 12. And this will give us 2 solutions. X equals 3 and x equals negative 12. Again, if one of those values was 0, then you would not accept it, because you have assumed from the very beginning, when you got this x away from the denominator, you are assuming that it's different than 0. So if at the end you get to something that says x equals 0, that's not a possible value and you will disregard it. Now the last example we're going to cover here is another fraction. So 4 over x minus 1 over x plus 1 is equal to negative 1. So what we want to do here is get rid of, first of all, get rid of the denominators. But when we do that, we will have to assume that x will be different than some values. So from the get-go, I do have x as a denominator here, so x will have to be different than 0. Also, x minus 1 is in the denominator, so if my x would be negative 1, this would be 0. So x has to be different than negative 1 as well. Now, if we want to get rid of the denominators now, we just have to consider those, and we'll have to multiply on top and below by something so we can get everything on the same base. So take a look. If I multiply this first term by x plus 1, so I'll multiply on top and below by the same thing. So I'm not changing the number. This could be 1 over 1, right? Remember that if x was negative 1, do you see that I'm multiplying this by 0 over 0? So this wouldn't be possible. Now the second term, I will have to multiply by x. And x on top and below, so nothing changes. The number which is on the other side, since I have multiplied, I need to get x times x plus 1 down here. I'll have to multiply on top by x plus 1. I didn't need a bracket here, but you get it. Okay, there we go. So now everything is on the same base, and if we're assuming that those values are different than 0 and negative 1, x is different than 0 and negative 1, we can just cross all of them out. So at the end, we'll have x plus 4 times x plus 1 minus x is equal to minus x plus 1. So now, let's just expand those. So 4x plus 4 minus x is equal to minus x squared minus x. And now we can get those to the left-hand side. So we will arrive at a quadratic, which is x squared. We can get rid of this negative x, which is the same on both sides, plus 4x plus 4. And this is actually a quite simple, equal to 0. This is actually a quite simple quadratic. If you analyze this, and you should be able to easily factorize this into x plus 2 squared. This is a perfect square, right? If I had a square with sides x plus 2, my area would be that, x squared plus 4x plus 4. That's why it's a perfect square. Now, this then is equal to 0, but this is only equal to 0 if x plus 2 is equal to 0 and x plus 3 is equal to 0. Those two conditions, they are the same. So if we use the null factor law, we're basically saying x plus 2 is equal to 0 or x plus 3 is equal to 0. Those are the two solutions, but they are the same. And this gives us that x is equal to negative 2. And that's our answer. If one of our solutions was x equals 0, x equals negative 1, then we would not be able to accept it. Now you can even get this value back to your original equation and check it out, and you would see that it matches. If we take negative 2 there, we would have 4 over negative 2 minus 1 over negative 2 plus 1 equals negative 1. So if you check 4 over negative 2, that's negative 2. 1 over negative 2 plus 1, this negative 2 plus 1 is going to be negative 1 down here. So that's negative, negative, that would be plus. And that's equal to negative 1.